Eureka!
The story so far. The greater the rate of change of speed, the greater the force required. Another word for rate of change of speed is acceleration. The more you accelerate, the more force you need. But force also varies with mass. So we say that force equals mass times acceleration. And now, acceleration, part 2. How do we measure acceleration? That's one way. But there's a better method. You see, most things do all the accelerating they're going to do in a matter of a few seconds. So it isn't very practicable to measure their increases in speed in kilometers per hour. Take this locomotive, for instance. It's a very old steam engine, and it can only do 36 kilometers an hour. But its acceleration is surprisingly good. It can get up to this speed in only 10 seconds. Yes, it is impressive. But can you answer this? How far will it have gone by the end of the first second? Or by the end of 10 seconds? Give up? That's what comes of mixing speed in kilometers per hour with time in seconds. We've got to reduce it all to seconds, and we'd better reduce the kilometers to meters as well while we're at it. The train's top speed is 36 kilometers an hour, which is the same as 36,000 meters in an hour. Since an hour contains 60 minutes, we can divide 36,000 meters by 60 to find out how many meters it goes in 1 minute. Then we divide again by 60 to see how many meters it'll go in 1 second, which comes to 10 meters in 1 second. So we now know that 36 kilometers per hour is the same as 10 meters per second. That means that once the locomotive has reached its top speed, it is covering exactly 10 meters of track every second that goes by, never less and never more. But remember, this is speed, not acceleration. Acceleration means that with every second that passes, the train advances an increasing number of meters until it's eventually moving at a speed of 10 meters per second. But it didn't start out that way. Ready? You've got 10 seconds in which to attain a speed of 10 meters per second. Very good. Now, let's replay that and analyze what happens. In the first second, you reach a speed of 1 meter per second and cover a small amount of railroad track. In the second second, you reach a speed of 2 meters per second and cover a larger amount of track. In the third second, you're going at 3 meters per second and covering yet a longer stretch of track. And so on until by the end of the 10th second, you're going at a steady speed of 10 meters per second and covering 10 meters of track during every second that passes from then on. Your acceleration is over. But how much was that acceleration exactly? That's right. Your locomotive increased its speed by 1 meter per second, every second. In other words, your acceleration was 1 meter per second, which physicists like to write like this. And that's how you measure acceleration.